Okay, so basically, scripting languages, of which Python is the example we're going over in this class, is that they're meant to accomplish specific tasks quickly without a concern for machine efficiency. So the emphasis is on your efficiency and being able to write a program quickly. And either the program is not going to run for a big amount of time, or it may actually require, say, an hour to run, but it would take you 3 hours to write the program in a conventional language like C or C++. And so you decide to write it in a scripting language instead. So when you're weighing up whether to use a scripting language or a conventional compiled language, what you need to ask yourself is two questions. First of all, will this procedure be used many, many times in the future? For example, if you're writing a library, the answer is yes. It will be used. So I guess questions, wow, just a moment. When I was writing a moment ago, the pen was working properly, but right now it's not working properly, so I have to. Okay, so questions to ask to help you decide or to help choose appropriate language. Okay, so question one is how often will the program be used? Okay, and the second question is how long is the expected running time of the program? Okay, so if the program is going to be used repeatedly, like in a library, then there's a good chance you want to implement it in a conventional compiled language like C, C++, Java. Whereas if this is a one-off that you're just writing quickly, for example, to compute grades in a course, it's more likely that you should use a scripting language because you're only going to use it once and then discard it. Okay, but the second question is also important. How long is the expected running time of the program? If the program is only going to take, say, fractions of a second or a second or two, even if it's going to be used repeatedly, you still probably would want to use a scripting language because whether you get the running time down from 1 second to 1/10 of a second really isn't important. Okay? Now, if it's a library and it's embedded in another program, that's different. But what I'm talking about, standalone program, it takes a second to run. Well, it's still fine to use it in a scripting language, even if the program would be used repeatedly, because reducing the running time from 1 second to 1/10 of a second, which you might do using a compiled language, is just not worth it. Okay, but on the other hand, if the expected running time is on the order of hours, let's say you're running simulations, you should write it in a compiled language because that's, in that case, if you expect hours of running time, then compiling it will get you a big speed advantage. So the answers to those two questions are going to allow you to choose the appropriate language. Now, having said that, when I am doing what I call exploratory programming, I often first use a scripting language. So I might be trying to devise a solution to some problem or prototype a solution. And in that case, I find it quicker to use a scripting language during that exploratory process. And then once I have a solution, then convert it into a conventional language like Java or C or C++. So that's can help a lot when you're still in that early rough draft stage. You're trying to get flexibility. Not necessarily something that you would encounter here at UT because the programs you write are pretty small. But in the real world, where you may be working on big programs, you actually may find it useful to play with a scripting language solution to a problem before tackling it in a conventional language, because you may be able to try out multiple different solutions, show your boss different potential solutions quickly, and then you can convert to a conventional language when your boss gives you the okay. So kind of a third thing here is they are good at prototyping solutions. So that's a third task that kind of the goal for them. So any questions about that? Okay. So here are some characteristics of scripting languages that make them differ from conventional languages. So the big thing is what is called economy of expression. That's the overarching goal for scripting languages, is that you should be able to write a program with as few lines of code as possible. Now, Perl probably took this too far, okay? It's been called a write once, read never language, okay? So it truly was designed for one-off tasks where you never expected to use it a second time. Of course, we know it became very popular, and it often is actually released into production. But the idea is that you should be able to very quickly write and test a program. So the way that they get this economy of expression is through these remaining features. So lack of variable declarations. In scripting languages, you are not required to declare a variable. You can simply write A equals 10, or you can write A equals Brad, and it will perform the assignment. It will set up the variable for you if it's not already been created, and it will give it a value. And in concert with lack of variable declarations, we have what is called flexible dynamic typing, which means that the type of the variable is dependent on the value currently assigned to it. So if 10 is currently assigned to A, it's currently treated as an int. If the string Brad is currently assigned to A, it's treated as a string variable. So unlike conventional languages, the type of a variable can change throughout the program if you assign different values to that variable, and the different values have different types. Okay, so not having to write variable declarations can save you a fair amount of code. Now, does anyone know what the potential disadvantage of not declaring your variables is? Pardon? Readability, well, maybe, because just looking at a statement, you don't necessarily know what the type of a variable is, okay? But just like if you just look at a line of code in a conventional program, you also won't know immediately the type of the variable. You'd have to flip up to the type section, or you'd have to float the cursor over it. And a good IDE for a scripting language will be able to tell you what the current value of the variable is and what its current type is. So I would tend to say, yes, Phil, but it's not a big thing. There's a bigger reason. Yes?
You can't depend on, or you can't assert what the type is going to be. So if you're trying to combine a string with an int, you might not be able to guess what the behavior is going to be.
Right. So one problem with the lack of variable, I'll say that you can get unexpected behavior. That would be otherwise flagged as an error. Okay, so let's say that you have something like A equals 20, B equals 10, and you write C equals A plus B. In a conventional language, you would get an error message saying that A and B have incompatible types. In a scripting language, you might get either 30 as an answer, or you might get 2010. Okay, how would I come up with 2010? String concatenation. Okay, it's not even clear which of those two you meant. But the scripting language will make a decision for you. Okay, let's actually show you that. So let's do it in Python. So I'll set A equal to 20, and B equal to 10, and I'll set C equals A plus B. Oh, they gave me an actual error. Type error, cannot concatenate. That's interesting. That's newer in Python. Okay, let's see if we can do it in Perl. Wow, they don't allow it either. Okay. Well, scripting languages have gotten a little bit more rigorous than they used to be. It used to be that they would actually do it. But I will still say that there are times, obviously not in this case, but there are times when what will happen is that it will convert one of these two to the appropriate type. And then it will perform an actual operation on it. Okay? Now I'm pretty sure that I can do this. No. Boy, Python is a lot more strict. Let's try that in Perl. I'm doing something wrong in Perl. Okay. Sec, let me do this. Oh, I know I was doing wrong in Perl. I wasn't giving it the... Okay, so let's try this in Perl. $B equals 10. $C equals $A plus $B. Print $C. There we go. So Perl actually converted that 20 to a integer constant and performed addition on it. Okay, so that could not be perhaps what you wanted. Perhaps what you really meant to do was string concatenation there. Just a sec, Phil. I'll get to you in a moment. So that's an example where a compiler would have flagged that as an error, but Perl didn't, And you might have expected to get 2010 there because maybe 20 was simply meant as 2000, right? So instead of 19 something, we want it to change our year to be 2000 and something. But instead, it returned 30 unexpectedly. So you can get unexpected behavior that would have been flagged as an error by a compiler. Yes, Phil?
I'm curious, if you switch the assignment from A plus B to B plus A, would it give you an opposite? Would it convert it to the other?
I doubt it, so let's give it a try though.
Always just going to go.
I'm guessing it's always going to go, but that's a great question. So let's just switch the order of operations. And it's still 30. Okay. So Python, in the old days, Python was willing to do those conversions for you too, but it's clearly, let's see what version we're running. 2.7.5, so I don't know how far back I would have to go before you got more strictness. Okay, so here's the other issue, is that, okay, so one, you can get unexpected behavior that would have been flagged as an error, and two, it may not flag the use of uninitialized variables. Because you've not declared them. So you can use a variable in some languages before it's been declared. And it will simply be assigned a default value in that case. So in Perl, well, in Python, it looks like it's going to be a pill about it. So if I say b equals 10, then I try to print a plus b, it says a is not defined. So it's forcing a to be initialized. However, I believe if I do this in Perl, okay, so I have not declared a or assigned it a value, but it was perfectly happy. What do you think it did? Based on that, it assigned it 0, okay, without any error message. So in some scripting languages, they will not flag the use of uninitialized variables. In others, like Python, they will, okay? But the lack of variable declarations can sometimes lead to unexpected behavior. I actually am pleased to see Python catching it because it does mean that you wouldn't run into typically problems 1 and 2 in Python. But in Perl, you can definitely run into that issue. Okay. So the next thing that's often provided by scripting languages is easy access to the underlying system facilities. And typically that will be done in a application or in a system independent way. So you don't have to worry which platform you're running on. So Python provides ways to list the contents of a directory, to open files, to read files, to move files from one directory to another directory, to delete files, that is platform independent. And they will translate those commands into the appropriate file commands for the underlying platform, whether it's Linux, Macintosh, or Windows. And some languages, like Perl, will actually give you access to the native platform's commands, although that makes your script platform dependent. So in Perl, you could actually execute an ls command. Okay? Python may give you that capability as well. I haven't ever tried to use Python to do system-dependent operations. Okay, the next thing is sophisticated pattern matching and string manipulation. So almost all scripting languages give you a way to provide a pattern and then manipulate strings based on that pattern. For example, a date might be \d, say 2 slash, or not slash dash, \d 2 \d 4. Now, you may have trouble reading it. Don't worry. That's what's called a regular expression. And that's what most languages give you, is the ability to write patterns as regular expressions. The \d means a digit from 0 to 9. And the 2 means that there must be 2 of them. So you're saying this is a pattern where there are 2 digits, followed by a dash, followed by 2 more digits, followed by a dash, followed by 4 digits. Okay? And they can be more flexible than that. So we know that days and months sometimes have only a single digit. So you might be able to write 1, 2 dash 1, 2, and maybe we want to require that it start in the year 2000. So that's saying 1 to 2 digits for the month, 1 to 2 digits for the day, that the leading character for the year must be 2, and then 3 digits after that. So that gives us even more flexibility in finding patterns. So you specify these patterns, and you may either use them as search patterns to extract all strings that match this pattern, or you could use it for type checking. If someone has entered a date, you could use this pattern to type check it to make sure that it corresponds to a date that you expect. Now, obviously, this only handles syntactic features of the input. It doesn't handle semantic. So if I want to make sure that it's a legitimate month between 1 and 12, I would need to have an additional check. If I needed to make sure the day was in the appropriate range for that month, I would have to do additional checks. So you can't do semantic checks with these pattern matches, but you can do syntactic specifications. So almost all modern scripting languages give you these regular expressions that allow you to do sophisticated pattern matching and string manipulation. Okay, so something you might want to do is reverse the day in the month, because maybe you want to convert from Europe or from American standard to European standard. So in the US, it's month, month, day, day, year, 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 year. But in Europe, typically goes day, day, month, month, year, 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 year. And they would give you ways to change that. So you might see something where it's \d 1, 2, \d 1, 2. I'm going to just make it D4. And you see them in parentheses. And that would do what's called a capture. I'm not going to hold you responsible for knowing how to do this. I'm just telling you. So you do a search and replace, and you might replace it with a pattern that is $2, $1, $3. So that says take what is captured here, which is the month, okay, and make that be that's the day, make that be first. Then take what was captured first, which is the month, make it be second, and so on. So that's the string manipulation part of it, that you can not only match a pattern, but you can rearrange the parts or substrings in that pattern. Pardon? You mean today?
Yeah.
Huh.
It's not like I would call it like a watercolor.
Effect? Oh, you're right. I think that's because it is doing it in PowerPoint. Normally, I'm not using PowerPoint. Normally, I'm writing on top of either the browser or on top of Notebook. So, sorry if that's kind of bothering you. I can see why it might. Okay. But it's almost over. Okay. So, the next thing is built-in high-level data types. So, they have types that are built into the language, typically lists and hash tables, which are called associative arrays. And they are part of the built-in syntax for the language. So for example, in Python, if I want to create a list, I just use square brackets, and that creates a list of 3 items. Okay? Or I can create a list of a shopping list, so milk, oranges, apples, and it provides built-in operators for iterating over it. So I could say for item in A, print A. Whoops. How about for item in A, print item? So it has natural syntax for iterating over lists. It is easy to insert. So I could say A of 2 equals cantaloupe. And what this will do is insert it after, it will insert it where apples currently is. So it replaced apples with cantaloupe. Okay. I can take slices of a list, which is kind of cool. So this will give me the items 0 and 1. So I can do all kinds of interesting things with the lists that are built in. Yes, Phil?
What's the significance of the fact that when you give it the value, you have to put it in double quotes, but when it prints it back out, it's in single quotes?
Okay, the significance of that is Python doesn't care whether a string is in single quotes or double quotes, so it's just simplifying. So Python allows strings to be in both double or single quotes, and there's really no difference. In Perl, there is a difference, which is string interpolation, but Python does not support string interpolation. So you can do it either way. I'm just so used to using C++ syntax, I just always put it in double quotes. Okay, but you feel free to put it in single quotes. There's no difference. Okay. Actually, let's test that for a moment. I'm just going to print ABC, and let's see. Nope, see, even that goes. There's no, it just literally, you can't even put control characters into it. It just thinks it's a backslash and an N. So that's actually not true. Backslash makes it think that it's still a new line character, but it's you have to do something special to get backslashes in there, I believe. If I do, yeah. So backslashes literally do escape something, but backslashes literally escape, but backslash n is still just being, I believe, escaped as n. If, for example, you want quotes to go in there, so if you have quote Brad, okay, now you see double quotes because it's making it clear that. So if you want to put a quote or a single quote in, you have to put a backslash in front of it. Okay, but you can do all kinds of nifty things with lists, and if you look at the notes, you can also see how to insert into lists, how to remove items from lists, etc. You can also go from the back of a list, which is kind of neat. So we have A. If I say A of -1, that gives me the last item in the list. A of -2 gives me the second to last item. So that's pretty cool that you can use negative indexes to get items from the back. So you don't have to say stuff like a of a dot size minus 1, and then you find out that size is not even the right thing, so it's much easier and more straightforward to get to the back of items in the list. Same thing with hash tables. Hash tables, you initialize them, I believe, with curly braces. So you can say Brad. Sure this works. Nope. Let's go and take a quick look. That's that was Perl that I was doing, so let's take a quick look at Python. There we go. There we go. So in Python, it is curly braces, but you put a colon between the key value pairs. So there I'm initializing. So here I'm initializing it to two pairs, Jack and Sape, that have the values 40, 98, and 41, 39. Then using array notation, which is why they're called associative arrays, you can obtain values. You can delete easily using del. You can insert new values right here. That's inserting a new value or key value pair. So it's very easy to deal with dictionaries in Python. Easy to create them, easy to deal with them or manipulate them, and you don't have all of the extra syntax that you have from either the C++ STL library or the Java collections. So you will find both dictionaries, you'll hear them called dictionaries, you'll hear them called associative arrays. They're really implemented as hash tables, so you may hear me call them hash tables. But hash table, associative array, dictionary, they're synonyms. They all mean the same thing. Okay? Order, constant time access, basically. Okay? And in fact, if you look under the hood, so to speak, at Python and look at how it is maintaining its symbol tables, it's using dictionaries as well. So when you say A equals 10, B equals 20, it's actually creating its own dictionary and storing those pairs into the dictionary. Okay, and the final thing that makes them much faster is that they're interpreted rather than compiled. And that means you don't have to recompile and relink every time. You can simply write a program and immediately execute it without the overhead of compiling and linking. Now, that comes with a trade-off. What's the trade-off? Efficiency. So when you compile the code, not only can you optimize it, but if you see something like C equals A plus B, and because you had to declare the types in a compiled language, the compiler would know that it should put a machine language int instruction. Machine language integer add instruction. But an interpreter isn't going to know that. An interpreter is basically going to have to say, what are the types of A and B? And based on the types of A and B, what they currently are, it will choose an operator like integer addition or floating point addition or string concatenation, or maybe something else if another value supports the plus operator. But the interpreter is going to have to do an if, type equals int and type of B equals int, then integer add. That's a lot slower than just immediately executing a integer add operation. So compiled programs will run much more quickly. Remember when I was warming up, I was saying it might run 1 second in an interpreted language and 0.1 seconds in a compiled language. And that's often a rule of thumb, is that a compiled program will run about 10 times faster than an interpreted program. Okay, so there's a trade-off. But remember, that's the trade-off that we're willing to have. We'll trade machine efficiency for programmer efficiency. So when it's interpreted, what it also means is that if you encounter a runtime error, you can dynamically patch the code. You can load a new definition of a function and start the program up from that point, and as long as you've corrected the error in the function, the program will continue to execute. So maybe you find out 5 minutes in there's a bug in your program, but it's fixable. You just patch the function and reset a couple variables so that they have the correct values and start it up from that point. You don't have to shut it down, recompile, and start from scratch. So interpret it can help with debugging. It can help the program finish more quickly if there's some error and you just want to fix it. But in general, interpret it helps a lot with debugging. It makes it a lot easier to find what's wrong, makes it easier to experiment with patches, all without shutting down the program and starting it back from scratch. So these are the characteristics of scripting languages that make them so much easier to write than regular conventional compiled languages. And in fact, you'll often find that if a textbook gives you a pseudocode algorithm, that you can implement that pseudocode algorithm line for line in a scripting language, but you could not do that in a compiled language. So that is a lot of fun with like quicksort or depth first search or a lot of graph algorithms. You can take any pseudocode from a book and essentially translate that line for line into a scripting language and it will run, which I find to be pretty cool. Okay, in fact, in the video lecture for today, I did that with quicksort. I wrote quicksort, and it literally is going to look much like the pseudocode from a textbook. Okay, so questions about that. This is something not in the video lecture. So this is something that I love to ask a question about on both the quizzes and on the final exam. So if you didn't write it down or take a picture, it would be a good idea. Okay? Because this will come back to haunt you, pretty much guaranteed. Yep. Yes.
Could you repeat what's so very important?
You're talking about just
All the characteristics of the scripting languages. Why so the fact that they're designed for economy of expression and that these characteristics are what give them that economy of expression. Okay?